Hi, my name is Boyeon and I will talk about HTTPS security and third-party proxy authentication implementation. Project background. As people increasingly rely on data exchange, the dependence on the web has grown, making privacy protection a crucial issue. In order to address these concerns, secure data transmission through the HTTPS protocol has become an essential element. I thought there would be plenty of opportunities in the future to create actual HTTPS web servers. However, I realized there might not be many chances to dive into the detailed learning of how HTTPS security is achieved. Therefore, I decided to undertake a project to implement and explore the security processes behind HTTPS. Additionally, I want to learn the widely used third-party proxy authentication method commonly used in daily life. Project motivation and significance. Through understanding HTTPS servers, I hope to provide future users of my service with a sense of security regarding the protection of their personal information, ensuring they can use the services with confidence. Many modern applications nowadays employ third-party authentication. I will examine how this authentication process takes place. Project description. I utilized Java as the programming language and did not employ any other frameworks. My project is designed to be a learning experience for understanding how an HTTPS supports security principles without relying on existing libraries. To achieve this, I demonstrated the exchange of certificate keys for encryption and the encryption process between the server, client, and certificate authority. Additionally, the project explores the process of third-party authorization in the auth protocol. Project progress, target, and schedule of project implementation. Week 1, learn about HTTPS and its operating principles, conceptualize the program. Week 2, implement the exchange of certificates between the server and the certificate authority. Week 3, implementing the exchange of certificates and data encryption between the client and server for secure communication. Week 4, implementation of the main logic for HTTPS operation and implementation of third-party authentication. Purpose of the project. In HTTPS, encryption stands out as the most significant difference compared to HTTP. Encryption is performed using keys, and there are two main types, symmetric and asymmetric keys. Keys involve public and private key for encryption-decryption, offering higher security but with lower efficiency compared to symmetric keys. Therefore, data encryption in HTTPS is typically done using symmetric keys. Considering potential security vulnerabilities in this context, the mechanism in HTTPS supporting encryption involves encrypting and sharing the symmetric key. My project implementing this technology has contributed to a deeper understanding of these encryption support mechanisms in HTTPS. When observing contemporary apps, one can often find the prevalent use of third-party proxy authentication features. Through this, I have been able to comprehend the information exchange structure among the user, the app server, and the third-party proxy authentication server. And furthermore, I've gained a deep understanding of third-party authentication technologies where access tokens are utilized to acquire access permission, enabling seamless access to the desired application. Description of components. First, CA. Its role is to verify the trustworthiness of the server, create a certificate, and encrypt it with the CA's private key. The certificate contains information about the server and each public key. This certificate is then transmitted from the server to the client. Server. After obtaining the certificate from the CA, the server shares it with the client, allowing that the client and server to exchange public keys. This will be used to encrypt the client's symmetric key. When receiving the symmetric key from the client, the server can decrypt it using its private key. Client. Upon receiving the certificate from the server, the client decrypts it using the embedded public key of the CA for verification. If the server is legitimate, the client stores the server's public key from the certificate. Additionally, the client generates a symmetric key for encrypting, decrypting requests and responses, sharing it with the server. A server. A server that facilitates delegated authentication. It performs authentication on behalf of the server, granting the user permission to access my server. Project result. The code. The certificate is encrypted with the private key of the certificate authority, short CA, containing the server's information and public key. Therefore, the CA must process both the public and private key. It is crucial for the CA to validate the server and issue the certificate. Consequently, when the server requires a certificate, the CA validates the server's legitimacy and, based on that, generates a certificate containing the server's information and public key. In the server constructor, the server is designed to hold its information along with its public and private keys. The server's public and private keys will be used to encrypt and decrypt the client's symmetric key. In the code on the right, it illustrates the process of sending the server's information and public key to the certificate authority, receiving verification and obtaining the certificate. When the client attempts to connect to the server sends the client the certificate obtained from the certificate authority. Inside the certificate, the server's information and public key are encapsulated. As previously explained, the server's public key is utilized for encrypting the client's symmetric key. The server decrypts the symmetric key received from the client using its private key and stores it. This key will be used for encrypting and decrypting requests and responses during communications. The server decrypts the received request from the client and provides the corresponding service based on the request type. If an unsupported request type is received, the server will encrypt and send a response indicating that the request is invalid. The client is embedded with the public key of the CA, enabling it to decrypt the certificate. The code on the right illustrates the process of generating a symmetric key. The symmetric key, crucial for decrypting requests and responses, plays an important role. And it's worth noting that symmetric key operations are significantly more efficient than asymmetric key operations when encrypting, decrypting requests. In this context, asymmetric keys are used to securely share the symmetric key. The client decrypts the certificate using the embedded public key of the CA. It examines the server's information contained within to verify whether the server being connected to is the intended one. If confirmed, the client obtains the server's public key. This method implements the exchange of requests and responses between the client and server. When sending a request to the server, it encrypts the request, and upon receiving a response, it decrypts the response. If you intend to use the services of the delegated authorization server, you need to register in advance. Client ID and client secret obtained upon registration, or used for client verification when integrating with the server and are received from the auth server. If our service user have obtained a delegated authentication from the auth server, they need to receive permission to access our server. This permission is encapsulated in the access token, which can be obtained through the authentication code. The corresponding storage for this is the authentication code, kept in the form of hash map. Authorized users is a hash map that stores users corresponding to authorization code. This is used for the purpose of identifying users when issuing access tokens. This is a method of the HTTP client for obtaining the authorization code. It involves authentication through login to the delegated authorization server and receiving the authorization code. And here the following code demonstrates the process in which the server issues an authorization code if the user is valid through login. The user who has received an authorization code retrieves an access tokens from the auth server using this code in order to utilize our service. The auth server validates the received authorization code for each legitimacy. If valid, it generates an access token and delivers it. As mentioned earlier, the access token is a token containing permissions to access our service. To implement HTTPS functionality, create CA client and HTTPS server objects. In this process, the client needs to embed the public key of the CA. The server undergoes verification from the CA and obtains a certificate. The client, using the received certificate, verifies if the server it intends to connect to each legitimate. If validated, the client then retrieves the server's public key. Depending on the choice, the user can either log in to my custom HTTPS servers or initiate auth server 2.0 delegated authentication. In the case of delegated authentication, the user authentication with the auth server to obtain an authorization code. Using this code, the user then obtains an access token, allowing them to access the services provided. And here is execution. This is the setup process before communication between the client and server. The URL for my custom HTTPS server is set as www.comnet.com. And this is a process where requests are not sent if the server the user intends to connect to does not match the information in the certificate. This helps prevent situations where the users might unknowingly connect to a hacker server and send their information. And this is the login functionality of the HTTPS server. For understanding, the pre-decrypted view of the server's response is provided. Additionally, the client's information is naturally exchanged in an encrypted form. This illustrates the process of the third-party authentication. To aid comprehension, the exchange of authorization code and access token is demonstrated. Upon successful login, it showcases the utilization of services from my HTTPS server. And my project conclusion. Through this project, I hope not only for my understanding but also for those listening to the presentation to grasp how security is implemented in HTTPS. In HTTPS, data is encrypted using a symmetric key during communication. To address the security weakness of symmetric keys, the client encrypts the symmetric key with an asymmetric key and shares it with the server. The server's asymmetric key is shared with the client through the certificate obtained from the CA. To employ third-party proxy authentication, the client undergoes the authentication process with the authorization server, receives an authorization code, and then obtains an access token. This access token is used to access the services of the desired application. And here is the end of my presentation, and thank you for listening.